Hey everybody, Mr. Kolstad here, walking you through questions 1, 2, and 3 on the AP style review. I do want to point out that the AP style review is all no calculator, so do your best to try to work through that. Question number 1 says that if we have a function that's exponential 3 to the pi x, it wants us to find the first derivative. So we can use a shortcut there. And to use the shortcut to help you memorize, let's think through if this was e to the pi x. If it was e to the pi x, you would write the original and then multiply by the chain rule derivative of the exponent. So again, it'd be like e pi x pi. Because it's not e, we have to factor in the log of 3, and so we do that with natural log of 3. So this is a helpful way to help you remember the shortcut for deriving exponential functions. And so that matches up with letter E. Number 2 is giving you an original function. It's telling you that the inverse is going to be called g. It tells you that the inverse has an input of 3 at an output of 1, and it wants to know the derivative of the inverse at 3. Now, there's a couple ways we could do this. First of all, the logical way would be to find the inverse of this function, derive it, and plug in 3. It's not that simple. We cannot find the inverse of this equation very simply. So we use this process where we take, to find f negative 1 prime at the value a, we do 1 over f prime of g of that a value. So right off the bat, you're going to notice that they tell you that g of 3 is 1, which means on the inverse there exists a coordinate 3, 1. Well, that means that f of 1 is equal to 3. Okay? So that's the first step in this process of using this little rule for inverse derivatives. Step 2 would be to find f prime of x and actually plug in this number 1. Okay, so the derivative function would be 3x squared plus 2x plus 1. And if I plug in and find f prime of 1, I would get 3 times 1 squared plus 2 times 1 plus 1. That's 6. Step 3 to that function process would be to take the reciprocal of this number, which would be 1/6. So that would be letter E. Number 3 is kind of a tricky one, but if you understand the process of definite integrals, this should make sense. It wants me to find what value of k would give you a definite integration of 1/2 natural log of 4. So before we talk about what this does for us, let's actually solve this and see what we get. Okay, so in order to integrate that, I'm going to use u substitution of x squared plus 4. That means du would be 2x dx. So I'm going to have to 1/2 du to get x dx. And so if I rewrite this, okay, I have 1/2 1 over u du. And now I can integrate it. So if I integrate it real quick, that would give me 1/2 natural log of the absolute value of x squared plus 4. When you have a definite integral, your first step is to integrate. We did that, and now we need to plug in these limits. So I have 0, and I have k. If I plug in k, I have 1/2 natural log of k squared plus 4. If I plug in 0, I have 1/2 natural log of 4. If I subtract these two, that is how I get the simplified answer that they provided me with. So what I need to do is set these two subtracted natural logs equal to 1/2 natural log of 4. And the way that I'm going to go about solving k is combining these two natural logs using the properties. They both have a 1/2, so I can combine this as 1/2 natural log. This minus sign, the way logs works, is I can actually create a quotient and write k squared plus 4 over 4. And so if I'm solving this algebraically, the 1/2s cancel. The natural logs even cancel. And so I am trying to determine where k squared plus 4 over 4 is equal to 4. If I want to solve that for k squared, I would first multiply both sides by 4. Then I would subtract 4, and then I would square root. And there are actually two possible square roots, but I want to focus on the positive value. So the answer would be D.